record. Okay. Sige lang, gamay lang man to. I will recap na lang ina later, no. Anyway, so the rigid body is a combination of different points or particles, no, that are fixed with fixed distances within each other. So it can compose a solid particle, no, or a solid body. Okay. So rigid body, it's now a system of particles, no. It is now a structure of particles. And concentrated force. Most of our study here will be dealing with the vector quantity, a concentrated force, no. It's an arrow, no, usually denote by a arrow, no. So simply lang, okay. So just like this wheel, okay. So the wheel has a concentrated reaction, no, force from the rail.
Sleep ka din.
Okay, kindly mute, no? Kindly mute your microphone. Okay. So we have 3 laws of motion which are you already familiar with during your physics. The first law, when the body is at rest, and it will remain at rest if no unbalanced force, no? So if there is no acceleration, the body will remain at rest. The second law, if there is an acceleration, no, there's an additional force and an acceleration, of course the body will continue to move unless stopped by a certain force. And the third law, there's an action and opposite reaction if the body or the particle bumps, no, with another body. So if the two forces coincides, no, of course there will be an opposite and equal reaction. Okay, so much more on this, no. So again, let me go back to my slide before I proceed with my manual lecture. Okay, I prefer ang manual because I can be flexible enough in providing the sketch. No, so kita niyo yung slide again. We are being refreshed by the slide. No, okay. I need to admit some of our participants. Okay, so chapter 1, no, this week, the principles of statics. So introduction, fundamental concepts and definitions for systems, axioms of mechanics, introduction to FDD, parallelogram law, triangular law. Okay, so let me use my another tool, no, in presenting, no. So kitaon man. I will stop the sharing of my slide para makita nyo. Please mute your microphone para hindi mag-agaw, then proceed to speaker view para makita nyo ang aton nga discussion. I believe baliskad, no? So this is the correct orientation. Okay. Okay. So kay nasa aga, the same method ang gingamit ko, the same tool, no? I begin my manual lecture using this piece of paper and of course a pen. I'm more comfortable in using this now versus using only PowerPoint and digital methods, unless mayari ako diri sang pen digital, no. But for this is I think okay. I think kung klaro man, no, kung klaro man sa inyo, I think okay man ang ining procedure. Mas flexible gani ini. Makaubra ko sang kuris-kuris, and at the same time hindi mo ko gusto magamit sa whiteboard kay once na erase ko na, no, hindi ko na ma-present liwat sa inyo if mayara ko sang i-point out, no, in the previous diagrams or sketch. Okay, so please bear with me, no. Again, engineering mechanics may be defined as the science which considers the effects of force on rigid bodies. So we are actually particularly, no, studying rigid body mechanics, because engineering mechanics is so general. It includes also deformable and fluid mechanics. So rigid body mechanics is particular on the assumption that the body does not deform under any circumstance or under any loading. If the body, no, masubrahan sa load, if hindi siya mabali, hindi siya magbawod, no, pwede mabuka, pwedeng mabugto, no? Those are part of the studies in your deformable na. Diri bisan lansang lang, no? We study lansang. We assume that lansang is rigid enough. Okay? Bisan ano pa katonilada ang kakarga dira sa aton nga problems, we still assume that lansang is capable to withstand such force, no? Or the nail, okay? Or any other fastener. So it is divided, no, into two areas of study. We have statics, where there is equilibrium, and dynamics, where there is no equilibrium, or there is an unbalanced force due to acceleration. So mula na, no? Statics, dynamics. And under statics, based on my reference, this is by Singer, no? Singer ang author sini. We have to study the different force systems. No, we have three under that, and we need to study also their applications. Mulang gid ni, diri lang gid nag-revolve ang studies ng statics. Applications, we have also three, no, enumerated based on the book, no. And for dynamics, although this is not our major topic, but we still have an overview. It is under the dynamics, the study of kinematics and kinetics. Okay. Okay. So let me first, no, overview, no, hatagan akong overview. Kinematics is simply the study of the pure motion. Kumbaga, ano ang path nga ginaagyan sang particle, no, when there is a dynamic property na. Okay, it is pure motion, no? While kinetics, it is now a combination of the motion plus the force nga naga-aksaya. So this is more complicated than kinematics. Okay, this is just somehow geometry lang siya. Okay, while kinetics, you need to consider acceleration, force, the weight in order to solve for kinetics. But dynamics, again, no, is not our primary area of study. We are concentrated on this area only. Okay, so the force systems, before we get with the different force systems, we need to first to identify what is a force system. So simple lang man, no? Force systems are any arrangement where two or more forces, no, interact with each other in order to form a system. So, for example, you have this particle, then may mga force ikaw nga ga-aksaya. So, this is now a force system. There is a system, no? There are interrelated parts, no? Especially forces, no? Acting on a certain particle. So, force system can either be coplanar or collinear in nature. So, what is coplanar? If they're on the same plane, like this on paper, if these are the different forces, no, this interacts with each other like that, no. So theoretically, these are on the same plane. These are on the same paper, the same flat surface. So most of our analysis are in 2D for us to simplify the process of solving the problem, no. Mostly sa mga structures naton 2D ma lang, no. And later we will be learning coplanar, and I'm sorry, this is not collinear, but non-coplanar. Okay, correction, non-coplanar. And as it was what I've said, non-coplanar, if the forces are not in 2D but in 3D, like this example in this tripod, for example, this forms a 3D or a space truss, no? So we are now getting into the 3D study of forces. Mas budlay ni siya compared sa aton nga 2D. Okay, for example, ang mga towers mo sang cell site, towers sang transmission pylons mo sa electrical, tripod na lang, no, pinaka-basic, no. Those are 3D force systems or non-coplanar. They are not on the same plane, flat plane. They have now the element of another dimension. That's why 3D. Okay? So the different force systems are enumerated, no? These are what you call concurrent. Next is parallel. And last is non-concurrent. So what is the difference between the or among the three of these four systems? Ang concurrent yang force system, if the force is in coplanar, no, at the same time intersects on a single point. Okay, so they're concurrent. If they're meeting on a single point, it could be away from the point or towards the point. No, it depends. Okay, this is concurrent. Next is parallel. Of course, no, if the force or set of forces or the force system is in parallel with each other. Just like, for example, in the study of your beams, okay? Most beams carry parallel forces. These are forces that are parallel and does not intersect with each other, okay? Those are parallel force systems. And lastly, non-concurrent, if it is not well defined and somehow the forces acts randomly, there are no meeting in a single point at the same time, hindi man tanan parallel. So those are non-concurrent force systems. Okay, so ini ang aton concurrent is very important later in the study of trusses. The parallel naman is important for the study of beams. Okay, that is why the applications now will go to trusses, centroids. I don't know kung naka-on pa ni siguro. Let me share screen. Okay, wala naman sang sound. May naga... Okay, wait lang gid class ha. Okay, so centroids and friction. Okay, so trusses, no? What are trusses, no? Ang trusses, simple lang. If ang iban sa inyo ay pakilas ng trusses, no? But in the building design, we have already encountered trusses. These are structures nga mostly gina-compose ang triangles. Just like your roof, no? Roof trusses mo, bridge man na, no? Towers man na, no? These are mostly composed of triangles. Okay?
Excuse me, sir.
Yes, you have questions?
May mapa-admit tani, sir.
Okay. Let me see, no? Okay.
Kag ang record gali, sir.
Wala pa nag-record? Ara na, ongoing naman
okay,
tag
nagali, sir.
record. Oo. Ang admit na lang, no? Pangitaon ko, anay.
Yes, sir.
Dali
Thank you,
lang.
sir.
Okay. Admit. Okay, participant. Dali lang ha. Waiting room. Enable waiting room. Napangita ko pa kung sa di ano. Hindi ko abi sanay mo. Sanay sa ini. Laka lang ko gagamit. Subong lang gid. Okay, gallery view, speaker view. Okay, anyway, invite, mute. Hindi ko makita bi ang nagagwa bala sa waiting room. Ari na. Okay, admit all. Naka-scroll down gali ako, that's why hindi ko makita ang waiting room. Okay. So let's go back, no? Let's go back to the topic, no? Trusses, no? This is most common sa aton sa engineering. Trusses are very important. These are lightweight. No, the advantage of these trusses are lightweight, yet stiff and rigid structures. But trusses still deform, no? Why isang object na why ka deform? We are still computing for the deflections. Because if the deflections in a certain structure is excessive, it will somehow affect or damage your non-structural components. For example, your windows, your ceilings. Sometimes kung ga-deform and ga-vibrate siya, mabatsagan sa occupants. So we need to limit those. But that is now the concern of your higher subjects. Okay? So centroids, of course, if you will study dams later on, especially if the dam is a gravity type of dam, in which there is a pressure coming from water. No, if this is the level of water, there is a pressure acting on the dam. Okay, it's a triangular pressure, no, loading. So if the dam is gravity, it is relying on its gravity. Centroid is very important to locate in order for us to calculate if the dam will overturn or not. And lastly, for friction, you will mostly encounter later on study about, it's like a block of wood on top of an inclined plane. Okay, and what is the minimum force, no, needed to let the cube slide? So there is friction on the other hand. So friction is very important. One of the most important applications of friction, no, if you may let me draw something, is on the banking of highways. What is a banking of a highway? For example, this is the cross section of the road, no? Kalsada ni aring center line. Ani kahoy bin no? Balanta kahoy. Kahoy man ni. Dahil ikaw ni ga-drive, no? This is a front view of your sports car, no? Balanta sports car mo na, okay? So, when you go fast, no, sa isa ka curve, highway or racetrack, there's a tendency that maapok ikaw due to what force? No, centrifugal or centripetal. No? Okay? You review that, okay? Ako nalipat man ko. So there's a tendency nga mag-slide na siya, or the worst, mag-overturn. It will tip somewhere here. Mag-overturn ang imo vehicle, no? O madisgrasya ikaw. So in this study, no, we need to bank the highway. We need to somehow super elevate or incline the highway para mabuligan natin nga hindi mag-overturn ang vehicle. At the same time, there is a considerable effect from your friction. Okay? So friction is very important in our study. Kaya bisan ang mga columns natin later, the steel columns on base plate resting on top of a concrete pedestal, no, with anchor bolts, will somehow rely on friction, especially if there is a force acting opposite. So imbis nga mag-act dayon ang aton anchor bolts to resist the shearing effect, no, there is still friction between the base plate and the concrete. So friction is important, no, in our practice as civil engineers. Okay? So going back to this, no, amo lang gini, this will be the only areas that our study will revolve for about a semester. But mind you, no, medyo madalman pa kita because especially in the applications, medyo lawig gawa ang aton nga mga practice in solving. So I preferred nga muna nag-lecture ako manual so that you can question me at any time. Kung tamad lang ko siguro mag-lecture, nakapoy ako, then I will record my video and let it sulit-sulit na lang sa inyo. But in these critical areas, no, ining pinaka-permiro sang meeting, I preferred nga mag-manual gid, just like this, so that you can question me at any moment. No? Okay, so that is a force system, and those are the applications. Let's go to the axioms or the applications of mechanics, especially statics. Ano gid bala ang axioms, no, of mechanics? What are the underlying principles? When you say axiom, no, axioms of mechanics, when you say axioms, these are generally accepted mechanics, no, generally accepted truth or principles about the study of mechanics. These are principles, okay, postulated upon several or more or less self-evident facts which cannot be proved mathematically but can only be demonstrated to be true. So fortunately, ang aton nga kalibutan, may mga bagay-bagay nga hindi mo ma-explikar mathematically and scientifically, but true, no? Okay? So, number one, for this, no, there are four. I will enumerate na lang and explain na lang later. And in the progression of our study for the whole semester, we will tend to understand further ining mga principles sa mechanics. Please, no, bear with me. Please understand well, study well sa statics. This is very important and crucial part, especially sa design. If you are very fond of designing and looking at mesmerize kagid, no, mas na nga tingala mo gid ang mga structure nga gatindog and ara sa equilibrium, it is because of mechanics, the very basic or fundamental level, no, in structural engineering. So we have the parallel law or parallelogram law, I mean, parallelogram law. Okay. So parallelogram law is, it means that the resultant of two forces is the diagonal of the parallelogram formed on vectors of these forces. So simple lang man eh. Later, we will still have um, time, no? If may force ka dire, kag force ka dito, of course, the resultant here, R, is part of the parallelogram. Okay? It's a parallelogram. Okay? Need to highlight this, no? Amuna, and this is the resultant, that is the parallelogram. In physics, I believe, na-study nyo ni. Okay? Number two forces are in equilibrium only when equal in magnitude and opposite in direction and collinear in action. So, no need to state na, no? Ang ilang botslingon, the third law of motion, no? If may two forces nga collinear, the same magnitude, no, and of equal magnitude, yes, equal magnitude, same direction, collinear, they are believed to be in equilibrium. Okay. Number three, a set of force and equilibrium may be added to any system of forces without changing the effect of the original system. How can we do that? No, again, let me repeat. A set of forces and equilibrium. Let's say you have a beam and there are already forces, no, on that beam. It could be away or towards the beam. And this set of forces are already doing equilibrium sa beam. The beam does not move, does not accelerate. It is at rest. So, pwede ka ka-add other forces, luwas dira, no, on the original set of forces. But there is an effect sa reactions. Of course, the reactions will be somehow increased because of these added forces. But still, the whole system will remain, no, at equilibrium. Okay? Pwede man na naton gyapon ma-achieve. Okay? In the actual application of this, if you will tend to increase the load of your beam and the supports cannot withstand the increasing load, pwede mabuka ang support, madagdag imo beam, tigok. So that's a failed structure. So, but in mechanics, we assume nga ang mga body are rigid, the supports are adequate enough to resist increasing loads. Okay? And number four, action-reaction forces are equal but oppositely directed. So, those same mangyapon concept, if they are going away, it should be opposite. If you are going towards, they should be also in opposite direction in order to cancel each other. Okay? So, ang mula ng axioms of mechanics, no, parallelogram, just play with the parallelogram, no, action reaction, and we will go deeper na, no, later on. Okay? These are just the basic. Okay, so now we will now go to free body diagrams. We have still at least 30 minutes now. Free body diagrams. What is a free body diagram? No, and also ang Zoom nag-prompt naman sa akin that 10 minutes na lang bilin. Okay, anyway, unahan ko lang siya. If you have this structure here, this is a derrick, no? You know what is a derrick? Sa mga manugsiman, you know what is a derrick? No, I think it's a structure na ginagamit sa mga port kag sa mga barko. It's a type of crane. No, this is just an exaggerated example of a derrick. no, medyo ginapadako ta lang para mas makita ta. So this is a pole, no, this is an elevation view or a section view. This is a pole that it is locked between surfaces. So may surface ka sa babaw, these are rigid surface, and also a surface, no, these are rigid surfaces. And this direct, no, in order to function, may boom na siya. And diri sa babaw, somehow may pulley na siya. It's a assumed frictionless pulley. And somewhere around here, somewhere sa may surface, there is a support, an anchor, kung sa diin ang string or ang cable is attached pakadto sa pulley, pakadto sa punta sang boom, and carries a load, a weight. So basically, ang derrick daw crane siya, no? We need to pull this in order for us to haul the weight. So now, okay, so before we proceed, I think mas maayo siguro nga because 30 minutes naman lang ang bilhin. I will reopen na lang another group, another conference. Okay? So we can continue with this sige-sige, no? Because may interrupt lang man daw, kasayang lang man. Okay? So let me again, no, end this. Okay?